Hello. For those who don't know me, my name is Gareth. I'm originally from Scotland and I've lived in Australia for the last 3 years. I've been developing for iOS apps for the last 10 years. Started using Objective-C, UIKit, moving on to Swift, and then most recently Swift UI. In that time I've worked on all sorts of apps, brand new, greenfield projects where you get to make every decision, and then older established apps where you're carefully extending something else that someone else has touched. I'm currently working with Intane, you saw the background there, and was working recently on a performance problem that was raised by QA. They're some of the trickiest bugs to find because they're really hard to pin down. There's often no crash logs, there's no obvious ways to reproduce, and you just get kind of the app's just slow. And while I was digging into it, I found a major memory leak. And this got me thinking, every single app I've worked on in the last 10 years has had at least one memory leak. So my theory is that your apps will too. My first job in Australia was with Kogan, where I discovered a major memory leak with their implementation of the coordinator pattern. Before that, when I was working in the UK, working with UIKit and kind of view controls and all that stuff, it was a lot more common to have memory leaks, so it's not as talked about now. So yeah, this is what the talk's about. Your app will have memory leaks. I'll walk through how to spot them, why you should care about them, what's the most common memory leaks are, and then hopefully I'll do a demo if everything works for me. And yeah, before I started, I want to kind of highlight it's important to be careful with this sort of stuff. So back when I was a junior developer, I spent over a week of my life in instruments trying to figure out a leak. It wasn't a leak, the tool was doing exactly, it was holding on to things that it was supposed to, and I assumed it was a leak. It took a week of my time. So yeah, just be careful when you're using these things. Really easy to go down a rabbit hole, so just, and really try and understand the tools that you're using before you start using them. Okay. So, what is a memory leak? So iOS usually manages memory remarkably well. When an object is no longer needed, the system uses automatic reference counting, or kind of ARC is usually what you'd usually see, to free that memory automatically. Most of the time, you genuinely don't have to think about it until something goes wrong. A memory leak is when your app holds on to memory it no longer needs. The object should have been destroyed, but something is still holding a strong reference to it. So ARC can't deallocate it, and deinit never runs. The important thing, one leaked object probably doesn't matter, but these things build up over time, and that's why you don't see the problem happening until further down the line. Every time you open the screen, you might have a timer that's running. That continues to go in the background, that's when you start running into problems. So why should you care? I watched a talk last week from Apple who said, it's all about your user experience. If you've got memory leaks in your app, you're going to have a bad user experience. The most problems you'll have is kind of your app will be more likely to be terminated in the background if you have a memory leak, because it's taking up more memory, and iOS, the system is just going to come along and say, this is too much memory, and close your app down. That means lost state and slow code launches every time the user comes back. So it's a bad experience, and something you really should. You want your users to get into your app as quickly as possible and into the place they were previously if you can. So that's one thing you really need to watch out for. There's silent bugs. The symptoms show up long way from the cause, which is exactly what makes them so painful to diagnose. You might think that devices have so much memory now, so why should I care? But it really isn't the safety most people think. Most devices do have lots of memories, but we're doing more kind of intensive stuff with them, so that memory is still really, really important. And particularly when you've got users supporting on older devices, you've got to think about what the user's experience is like on those older devices and not just the latest and greatest devices. Another kind of key thing is other apps. The more memory that your app uses, the less that is available for the system to give out to other apps. So have a look around. If you don't care about your memory, then your fellow developers will suffer. Performance. So as memory pressure builds, the system starts compressing, purging memory. The system does its best to keep things running, but it's only doing its best. So you'll see things like scrolling hitches, cache is getting dumped, everything slows down, and then in worst case scenario, the app will actually crash. So that's where the kind of the bugs mostly come from QA, is when there's a performance issue that's caused by a memory leak. It's the system just trying to cope with how much memory your system is using. And then yeah, battery. Leaked objects aren't idle. So if you have a weak screen that's got a timer on it, in the background, it's just going to constantly be on that timer, and it'll be burning the CPU and battery for the screen, and it's going to kind of, yeah, obviously not be a good user experience. So what are the main problems that cause memory leaks that you should be most careful of? I've got a list of, I think, 5 or 6 here. First, strong reference cycles. So 2 objects each hold a strong reference to the other, so neither can ever reach 0. So what Arc does, it counts kind of how many references to each one. When it disconnects from one, it reduces the count by 1, and when it gets to 0, that's when it's deinitialized. If there's a strong reference to 2, it never gets to 0, and there's no way for Arc to deinitialize that class. Yeah, so strong reference size is probably the most common one. The closure capture is probably the most common one. An escaping or stored closure grabs self strongly. So if you're in a class, you've got your closure. If you don't weaken self, that creates you've got a closure. Calling self from within that closure, you're going to cause a strong reference cycle between the closure and your class. Whoever stores that closure now owns your object. This is the one that I see most often. Timers that never stop. A repeating timer is retained by the run loop, and it blocks retained self. So you forget to invalidate it, and you've created an immortal object that also keeps ticking forever. Notification center observers that live forever. So because you mostly use notification center.default, which is a singleton, if you have a block-based notification center observer and you don't weaken self, that kind of creates a retain cycle by the center until you remove them. So if you just store the token, that's not going to be enough. You actually need to unregister it to actually get rid of that from the life cycle. Tasks, mostly unstructured, but they can happen in other ways as well. If you capture self over a long wait, the object will stay alive for the rest of that task. And the last one is not technically a memory kind of leak, but is one you should be careful of, is kind of unbound memory growth. It's an honorable mention, not strictly a leak. It just, if you've got a singleton of a cast that you're not being careful of, you can really let just memory grow and grow and grow. It's not technically a leak, but if you let it go too far, then you're going to be using too much memory. So it's something to be kind of mindful of what you're doing. So, time for a demo. Cool. So here's one I prepared out. Hopefully, that is not what I want. There we go. Cool. Okay. So, me and Claude had some fun this week working on an example for this. So this is kind of an example project that Claude's put together, and he's kind of put in some examples of leaks. So it's a very basic app. It's a cooking app, and kind of with some recipes and stuff like that. So there's a lot of leaks in here, and kind of, yeah, I'm going to walk through ways you can find them. So first off, it's kind of the most kind of giving tool is this memory here inside Xcode. This tells you kind of what memory is in the system at the time, what the usage is, and this is really kind of the first. If you've got a problem with memory, this is where you're going to see it first. So if I go into a view, I'll get this out of the way, I see it jumped up a bit. If I leave that view, what I'd expect is for that to come right back down to where it was previously. It's not done that, which makes me think there must be a leak within that view. So that's kind of my first diagnosis is something's going on here. I'm not quite sure what's going on, so let me dig into it a bit more. So if I do that again, let's do it a couple of times and see if there's anything happening. So when I go into the memory graph here, the memory graph is found at the bottom if you've not used it before. This is probably the most powerful tool for diagnosing memory leaks, and that includes the leaks tool that Apple provides. You can see here, this is a kind of a graph of everything that's currently in the system's menu. And so what I'm looking for in here is more than one object. So I can see this recipe detail view model. I've got 3 of those instances. That kind of makes me, knowing how this app was built, that was what this screen is. So when you click on there, it opened up the recipe detail. And so when I close it, that's not being deallocated. So that is a memory leak. And so looking at it, you can kind of see roughly what's going on. I'll make it bigger. So you can see the kind of thicker, strong lines kind of indicates a strong kind of reference between the two. And so it's very easy to see that I've got a closure that's capturing self here for that recipe detail. So you could go straight into recipe detail, go through it and try and find out what's going on. Or you can kind of click on this object, and what you can see is there's no backtrace. And so it's telling me malloc stat logging is not enabled for this process. So let's go enable that. So inside system, if you go to edit scheme, you've got the options, you've got your memory management things here. If I go into malloc stat logging, restart the app, and just to get that triggered. Okay, let me go into this view again and out again. Open up that memory graph again just down at the bottom here, beside your view debugger. And I'm looking for that recipe detail view model. So here it is now. I can see more of a backtrace here, so that's what malloc stat logging does. It shows you what the kind of the creation of that, where the object was created from. And I look into this closure, and it tells me exactly where to look. So inside the recipe detail view model in it, there's something going on there. Not that one. If I go into this top one, not that one.
You selected the view model again.
Yeah. Yep, that'll do it. I'll see here we've got favorite observed changes, and there's no weak self. So that's a closure that's capturing self. And so all I need to do here is a simple weak self. And I run that. Okay, so next time I run the app, I go into it a few times. Go into the memory debugger this time. You see it's no longer in memory, so that has now successfully deallocated that, and we've solved that memory leak. This is, as I said, this is my favorite tool in Xcode. I use it all the time. It really pays to be curious. So if you kind of see something that you're, in your memory graph, you're seeing things around a spike in memory, jump in here, just play around with it. It's really useful tool to use. The next up is kind of, you probably see it just at the bottom there. I've added in some logging. So what you expect when you initialize a view and deinitialize, that calls init and deinit, all calls by the system. So we can add tracking, like logging into that to make sure that all our view models are being deinitialized as expected. So I can see here that my recipe detail view model now was initialized, then it was deinitialized, and at the same time initialized and deinitialized. So that's kind of an easy way for you to go through and validate that this is working as expected. Next tool I wanted to talk about was leaks. As I said, I don't think it's as good as the as other tools, but I'll kind of walk through leaks. So if you open instruments, there's an option for leaks, and this will bring you into here. I've got an example of a retain cycle, but I'll do, before I get to that point, it's very easy for this to give you false positives. So if I run this app just now, it will give me the, that's what I get for trying a live demo. Okay. Right, so if I go into settings, developer tools, instruments, that'll be why, because I've got that locked down. So if I go into weeks now, I tend to like to, this is, the top one is more around kind of when you see it, so you can either have it immediately, or it can be deferred, kind of what you prefer. Most of the time I prefer immediate, so you just see exactly what's going on as you're going. Otherwise you've got to kind of wait for the thing to, the whole, what you're doing with the app to finish. So yeah, I'll start off here. We've got weeks that's going to capture every 10 seconds. So, this app here, I know there's a memory week within this class, but it's currently showing me green. There's green ticks, everything looks good. And the reason for that is because weeks only show unreachable memory. Most weeks aren't that, and so it's really careful. It's really important to be careful about that. So this example week that I'm showing you here, it's actually, if I kind of go into the code, it's a timer. So this timer here is the week, and it's because we've got week self, it retains itself. There's a few other issues here that we're not cancelling timers and things like that, but I'm not going to, I'll just focus on the kind of the memory week issue here. And so what that means is that the timer is there, it's not showing as a week within my allocations, or my week, sorry. And that's because it is not an unreachable bit of memory. So the timer is actually created by the run loop, and so that means it's got a strong reference between the run loop and this timer. And so by that, that means that your view model that's been created also has that strong reference back to the run loop. So there's that reachable bit of memory. I do have an example of an unreachable bit of memory. So let me just get it up now so you can see what that looks like. So it captures every 10 seconds. So yeah, cool. So this is an example of an unreachable bit of memory. It's a kind of coordinate and a view model that are created together, and they both hold a strong reference to each other. So first off, you can see there's a problem here. The best thing, you can see exactly where the week is coming from as well. I've got a demo child view model and a demo coordinator, so you can go in and look at that code to see what's going on. One thing I think is really useful is the cycles and routes. And so this shows exactly where that retain cycle is coming from. Yeah, so if it's a non-reachable bit of memory, this is really useful. Yeah, so we've got a demo coordinator and the demo child view model. So let me stop this and go have a look at what's going on there. Okay. So here, I've got a coordinator that creates a view model. Inside that view model, there is a reference to the coordinator. Yes, sorry, no. The view model is created with the coordinator. The coordinator is a strong reference, so that means that the coordinator and the view model can never be DNSized from memory. It's an easy fix, and it's probably, if you've worked in Objective-C, you've probably done a lot of this when working with delegates. We just need to make that a weak var and make it optional, and that weakens the reference cycle between the two, and it can be deallocated when it needs to be. I'll not show you that working because I'll need to get back to the talk, but yeah, that is roughly my demo. A few different examples of the tools Xcode give you, and it does give you a lot of tools. So it's really, yeah, know the tools you're using and be careful. Okay, so finally, just to kind of summarize that, be curious. If you spot something that you think, I don't think that's quite right, investigate, but be careful as well. When you're digging into these things, as I've learned myself multiple times, it's a rabbit hole that can be hard to get out of. So kind of time box it, make sure your time is, you set yourself amount of time to come back and say, I'm finished, this is sorted, or this is not a problem I can solve. It's okay to say that. Just kind of, to finish off, is probably my key message is be kind. It's be kind to your fellow developers, kind of think about memory, be kind to your users, think about their batteries, and with the new beta OSs using up all their battery, it's important that your app doesn't use as much. So that is my talk. Thank you. Any questions?
Thank you, Gareth. Any questions in the room?
Oh, good talk as always. Sorry. You mentioned Claude at the start.
Yes.
So this is a bit of a question in two parts. Have you experimented, used Claude to help drive instruments and do any of that sort of memory debugging?
Here's one I prepared earlier, because I thought I was going to have time for this. But yes, I've not used it to actually go through into the instruments, but I went on to basically Googled memory leak skill, used the first one and just kind of ran it as just a test. So hoping to find to get into the demo, but ran out of time, so thank you. Good to, it was pretty good. It kind of went through most of the issues that I had, and it kind of found all the problems that were put in by itself by another agent, but it found all the problems, and it was pretty good at finding them. So that's a very kind of small project with kind of very, very obvious leaks. So I'd be interested to see how it does work with kind of a wider code base than just these, and probably more challenging leaks to find than kind of the basic example ones.
Yep, cool. Thanks for showing that. Do you think the use of Claude to address and solve memory leaks is removing some of the curiosity involved?
Good question. I think I'm good through my time. I've always seemed to find memory leaks seem to find me, and I always be the one to find memory leaks. I don't know if it's me or. So I think I do love just digging into the tools, just really getting into things. So yeah, I think it's good for some things. It's good to help you, point you in the right direction, but there is still some kind of joy you get from that kind of craft of finding that issue.
Do you have a war story?
Yes, I was using a Weeks tool where I had an animation that was really slow, and I went through the whole thing and made everything weak self by the end of the week. At the start of the week I was going through just bit by bit, and then I got to the end of the week, and then I was speaking to someone, I was talking them through what was going on, and they said, you know, that holds onto things deliberately, that tool? And I went, no I didn't, and that's why everything was being held in memory, because that is exactly what it was supposed to do. So I didn't understand what that, I think it was a zombie tool at the time. I didn't understand what that tool was doing. So yeah, I lost a week of my time. And yeah, I've learned from that. Yeah.
Any more questions in the room?
No questions online? I think we're good.
Thank you very much.